Dan Fay, started in Microsoft in October of 1992 and have been there since until 2024 and was in various groups, mainly in Microsoft research. So I was born in Frankfurt, Germany. My parents worked for the U.S. government. So my dad was a principal for the military schools over there. And so I grew up there till I was 18, lived in Germany, then came back to the U.S. to go to school. We lived in Berlin for 5 years when the wall was still up, and we used to go, my parents were really, again, good about doing things and the arts and things. So they would take us to ballets and plays over in East Berlin. So we'd have to go through Checkpoint Charlie and come back through it. And, I remember times when you get pulled over to the side, and they would, these German police would, make really kind of check out the whole car to make sure we weren't bringing anyone back over. So it was definitely an interesting time. We were all, U.S. citizens, and we were living over there. My parents always had us kind of planning on coming back to the U.S. to go to different schools. And I was the youngest of 5, so I ended up going to the U.S. Coast Guard Academy for a couple of years, and then went to Northeastern Boston. The rest of my family was kind of in that area, and I ended up applying and getting in. And at that time, Coast Guard Academy isn't like the other service academies where you had to get a recommendation from your senator. It was purely competition based. When I ended up transferring to Northeastern University, there was a lot of work going on around computer engineering. And so it was more the ones and zeros, let's put it that way, more digital than some of the circuits part. And it made a lot more sense to me. And it was something I really enjoyed. So one of the things that was really fascinating and was good about, especially Northeastern, they have a co-op program. So you go go to school for 6 months, work for 6 months at a company, come back, and you go back and forth. And so one of the jobs I had was at Digital that I was doing my co-op with. And so it was kind of neat to be at that industry doing things at both the, kind of the mini computer era. And I was working with the hardware folks at the time. And so we were not only building machines, but supporting them. It was just really kind of a neat, again, really interesting time frame. After I graduated from high school, my parents moved from Germany to Japan. And I went one time to see my parents in Japan. We flew through Seattle, and we ended up having a flight delay. So we stayed overnight in Seattle. And I really kind of loved it, just being in there for a day. So I always thought, this would be a great place to, move to. And when I was graduating from Northeastern, I always thought it'd be a neat place to go. And I always kind of kept my eye out. Was looking through that time, the Boston Globe, and about, 6 pages deep, there was this ad for Microsoft. And so I thought, I could do this. Why not? So I applied, and after interviews and all that sort of stuff, ended up getting offered a position out there. So I did the NEO training, and then after lunch, went over to the building, and this was at Bellevue Place, and went and asked for the manager that I was supposed to report to, and there were a whole bunch of calling around, all this stuff, and I was sitting out there in the lobby for a while, trying to figure out what was going on, and come to find out that there had been a reorg, and the manager at the time was Libby Duncan, who I was supposed to report to, had moved to another job, and they ended up putting me into Premier Support. Not that I knew it at the time, but so on the first day, again, during the new employee orientation, and I think it was in Building 21, after the video and all the paper signing that we had to do, you lined up to get your badge. And I remember this person in front of me, so this woman in front of me, and, let her go ahead of me. And about, 4 or 5 months later, we ended up in the same group in project support. And so I met my future wife there. So our badges were always one number apart, which was really kind of unique. There was a position that opened up in this group called Developer Relations Group, which was something that I was always really interested in to be a technical evangelist. And at that time, it was they were looking for a technical evangelist for MAPI, which was the Microsoft Mail API that they were developing. So I went over and ended up being the MAPI technical evangelist for a number of years. So technical evangelist within, especially at that time in the developer relations group, was responsible for bringing out the details of and what we wanted developers to engage in at different ISVs or anywhere to program to the APIs that we had. So in this case, for the messaging API, but it really was about working with developers in the community and getting them to trust us and also to see why they would want to adopt our APIs. And at that time, there were a lot of different platforms that they could build for. And so we obviously wanted everyone to write for Windows. I always keep thinking about something that Bill Gates said, which was, there's the magic of software. And so you were bringing in that idea of, hey, here's this thing, you just write to it and you get this benefit. And so it benefited them and us. One of the things we ended up doing was, working on Windows 95 in general, kind of evangelizing it and bringing that out to the different ISVs and trying to get them on board. It was one of the first times we had done a kind of lighthouse project where we were targeting specific companies, especially the top ones in the different domains, to kind of get them to adopt and to write for Windows 95 before it released. One of the folks that I'd worked with in the developer relations group, this guy, Todd Needham, who I'd known for a number of years, ended up going over to research as part of this. They were setting up this university relations team. And so he ran across me one day and asked me if I was interested, and that's kind of how it happened. So ended up moving over to research into the university relations group, essentially kind of bringing evangelism to the universities and to researchers. And so it was kind of a similar kind of work, but working with the universities and the researchers on what their problems were and how our technology might be able to help and what research we had that could help them out as well. Part of it was there was a need for Microsoft and for Windows to actually get out there into the kind of research community and see it being used by not only the researchers, but then their students as well. And so that was one of the things we were looking at and trying to figure out how to do. At the same time, there was a push from the kind of, I'll say the industry at the time, mainly Intel, on how do we get PCs into universities. And so there was a whole push with shipping PCs to universities, but they needed obviously an OS to run on it. So we had partnered with Intel to supply the OS to the universities. And so that kind of was one of the pieces, and how could those be used? And it was really also at that time, remember, computing at that time was really only being used in a few areas. It wasn't being used like it is now across the board. And so there was a lot of opportunity to see not only how computing could be used, but how that could transform not only education, but also research in general in a lot of the different sciences. Early on, Todd and I were doing things around the high performance computing space, specifically around some of the network protocols, and working with the folks in supercomputing and other like big conferences. And we didn't, as a company, have a product in that space at the time, but we were working with universities to get them to implement Windows in this high performance computing, or that time was Beowulf computing space, and prove out that Windows could run in that area. And then later on, that ended up leading to a Windows HPC product that the company ended up putting out. And actually, a lot of that the HPC work is now some of the backbone of what's within Windows Azure as well, or Azure on the back end for the supercomputing portions. We had a couple of our folks within research, Curtis Wong and Jonathan Fay, who's not related to me at all, but create this thing called Worldwide Telescope in conjunction with some of the other folks, Jim Gray and others. But actually, let me take a step back. And so Jim Gray and Tom Barkley had created this thing called TerraServer, which was the first real kind of mapping service. You could think of it as Google Maps or Bing Maps at the time, which they took data from the USGS, as well as they got some from the Russian folks, and ended up creating a server where you could end up seeing all the images from a different machine, from your client machine, and be able to view those. And that piece ended up going into what was called Worldwide Telescope at the time. And with Worldwide Telescope, we ended up creating a 3D environment that allowed people to not only see all the images like that NASA had and some of the other pieces, but then also, images of the world and some of those. And so that ended up shipping out always as a kind of like a beta product from research. But one of the things we ended up being able to do was incorporate, we figured out how you could go from Excel directly and put your information, in this case, we started off with earthquakes, how you could plot those on the surface of the earth with the imaging there and the maps, and be able to zoom in and zoom out of it, but make it much easier for folks to actually plot stuff within Excel and integrate that within this kind of visualization environment. And that ended up being productized and put into Excel, and that was shipping for Excel for a while as a 3D kind of charting environment. So there were some things like that ended up happening at different levels, but it was always kind of seeing where that neat kind of potential of where the use is and where it could actually be used at, and how it would benefit folks. There were two parts kind of when the cloud computing kind of shift happened. One was that there had been work, and I'll say at national labs and other areas of this thing called grid computing, which was how could they at national labs share their machines between different research sites. And this was something that, again, we had identified, and I brought and presented internally to folks to say, hey, here's something we should be aware of. This is happening. They're trying to figure out how to use this stuff across the internet and across these networks, and share their material or their resources. And so that this was kind of ongoing. This was a way to help solve some of the science problems that they were looking at. And then at the time when cloud computing was kind of coming up, it was a very similar thing to say, okay, hey, we have this asset. You could use it for your science or your research. The challenge had always been when they started looking at it was the cost, because with academics, and what you did was you bought a machine and you paid for all that and got up and running, but they didn't pay for anything else. They didn't pay for the electricity or some of those things. And so it was felt like a one-time sunk cost. Whereas with cloud computing, it was this ongoing cost. So there was a real hesitancy to why they should use it. And so one of the things we were looking at was also, hey, how could we get them to use it? How could they benefit from it? And what could we learn as a company in this space as well from them, and how to use it? So it was one of those things recognized early on that it was, hey, this is like the new OS for the internet or for the web. And so had sat down and actually penciled out a program that we called Azure for Research, and ended up bringing this at the time to Satya, who was the head of Azure at the time, getting his approval for it, and then moving forward and getting it kind of rolled out to different universities and researchers around the world. So we had a small team where we were doing everything. We were getting the kind of courses together, samples up. We were going and delivering courses. We hired some folks to help us with some of the course delivery, and we were really trying to get that out over a couple of year period to get some visibility and adoption of Azure. And that was mainly also because we kept seeing Amazon and AWS being used within academia, and we didn't want to be left out. Because one of the things that I'd seen was, because Microsoft wasn't involved with the high performance computing early on and a lot of the Beowulf work, that whole area got dominated by Unix. And all the biology tools got written on top of Unix, on top of these Beowulf clusters, because it gave them something that they didn't have before. And so my concern had always been, are we going to run into the same problem with the cloud? And so really kind of wanted to make sure that we weren't left out, especially in academia, and making sure tools were written for Azure and not just for AWS. We were able to get, some free cycles from the company to allow our researchers to end up using it, the ones we were working with externally, and giving them that, and then kind of helping them get up to speed, help them. But we always ran into that transition of, okay, what do we do long term? Because we couldn't just keep funding them for their computations or using their virtual machines on Azure. So we were always trying to figure out how could this transition to something else, which has always been kind of a challenge in working with academia in general. You end up having a lot of you can spend a lot of money in those areas and not get a lot of return out of it. So a lot of it was actually working with them, trying to show that, hey, there are solutions there, and then that this could help them. But also, one of the things that why research is hard to do on something like cloud is you end up doing a lot of experimentation. And so if you're doing a lot of experimentation, that drives up a lot of costs. What the cloud was really good at is the ability to, once you have a solution, then to actually know exactly how much it would cost to run it. And so we were always trying to look for what places that you could do a little of both, where they could run it locally, but then execute it on the cloud once they kind of knew what they wanted to run, because there'd be a more fixed cost there. As one of the other things in going around doing a lot of these talks within the science community, I ended up talking a lot to folks from not only Department of Energy, but also like the EPA and other organizations. And in fact, and also the USDA. And so we got, as one of those pieces, got invited to participate in this, I think it was near the beginning of Barack Obama's time as president. They were rolling out, how could we engage companies with some of the different initiatives that they were looking at. And one of them was around climate, around the climate initiative. And so we ended up, as a company, signing on, being part of it. And we ended up creating, not only doing the press release, but also going to DC, doing a workshop there with the folks at the White House, doing some meetings there, and then also working with the USDA on a program to have some university researchers utilize Azure to actually do some of the computations for some of for that program. And it was a competition, and then that was kind of then they were awarded that. So it was it was kind of, again, that you're being there at the right time and talking to the right people, and end up having things come about together. There's a lot of things I kind of think back on that I really enjoyed and were particularly satisfying for what we were doing. Like one example was with the Worldwide Telescope work, ended up working with the folks out of Johns Hopkins who run the Space Telescope Consortium, and they're the folks that have the Hubble data. And as we were having a discussion and talking about it, there came about a plan to actually have us, so using Worldwide Telescope, and then the Space Telescope folks at Hopkins and Northrop Grumman, because they were building this thing called the James Webb Telescope, which is now actually, had been launched and actually is sending back images. but they had their full mock-up prototype, and we ended up bringing all three groups down, and with NASA down to South by Southwest in Austin with a big kind of pavilion, and we were showing off Worldwide Telescope, and then they had so it was kind of like two telescopes. We had Worldwide Telescope, and then we had the mock-up for the James Webb Space Telescope out on the field as well. And we were actually using our big wall that we set up for Worldwide Telescope to actually bring in real-time interviews from the clean room where they were building the actual telescope. So there were things like that we did. And then another one that came about, again, along those lines, was we got asked to do a demo at one of the TED conferences up in Vancouver. So we ended up having a large-scale display, a big wall display showing off Worldwide Telescope, but we also partnered with some other folks at MIT to show off neurons. So we could go from these really small neurons to kind of the universe, and we could scale in between it. So it was really before a lot of the VR type stuff got big, but it was a really neat way to kind of show how you could move between these different imaging systems. One of the things that was really kind of neat within research was, meeting some of the different researchers that had come from either their industry or from universities. And there were two of them that came in at one time. Eric Horvitz, who's now the chief scientist at Microsoft, and David Heckerman, and they were doing a lot on machine learning at the time. And some of the stuff that they ended up using was kind of an early cursor to a lot of what's in AI now. And one of the things people know from Eric is Clippy. So he built the back end system, or the system, out of research, and then the Office folks changed it and made it, Clippy and kind of a little bit more, and the letter wizard they did a little too much with it. But it was that type of stuff where it started early and then kept moving, and you kept seeing them using some of the Bayesian networks and some of the other technologies as early machine learning pieces in there, and that just kind of kept kind of marching along slowly in the different areas, from both the voice and some of the other areas, until kind of this last big change came about. So there's clips from one of the conferences a number of years ago where Rick Rashid was showing off doing live translation. I believe it was in Skype, language translation of his speech at the time. That was really really amazing to see that happen, and that really kind of foreshadowed what could happen. The potential for the technology and the really being limited by only maybe the imagination of everyone involved. One of the things I realized over the years was that Microsoft has a brilliant company, a lot of really great developers, technologists, and others. But one thing you end up needing to actually have some of these really interesting breakthroughs is you need to have the creative folks that also can imagine how these technologies could be used, and talking to people about potential solutions. And so that's where I always found the real, I'll say, the magic, and why I stayed was because talking to these scientists in these different domains and seeing, how we could couple software or, even hardware technologies with what they were doing. And was there something new that could come out of that? Or would it change how they were doing their work? And like for me, it's always been not about the task automation as much as about what's the potential for something brand new coming about. The company was and has been able to survive all these different paradigm shifts. If you look back in the history of a lot of industries, it's really hard for companies to navigate, to jump over one paradigm shift let alone, I don't know, I think we're at 3 at least now. And that really has made a, testament to the company not just sitting on the golden gooses, but also looking forward and investing in not only research, but other pieces, looking forward. I think for me, it's more that I always did the right thing for the company, but really, it's really important to always, sure you're doing the right thing that you can kind of live with and on your have your integrity at the end of the day.